Welcome back to Math 1500 Applied Business Mathematics, Connecticut State Community College. This is section 3, linear functions and models. So we're going to look at a linear function. I mentioned this in previous videos. What is a linear function? A linear function is a function that can be written in the form f of x equals mx plus b. Okay, so in the linear function, b represents the y-intercept or the y value of the intercept. That's sometimes the initial value. In a previous video, you might remember we talked about renting tuxes, where the cost to rent tuxes was $20. That was an upfront fee that I had to pay. That was my fixed cost of $20, and then we had a marginal cost of 88x. Okay, that 20 is the initial value. That's my y-intercept. Then we had $88, which was the marginal cost. That's the rate of change, or the slope, the rate at which the cost of renting tuxes changed. So m is slope for rate of change, b is y-intercept. Now I want to be very clear here. When you're doing homework problems in WebAssign, it will say b is the y-intercept. So for example, if f of x equals 2/7 x plus 5, and WebAssign asks you for the y-intercept, it will accept an answer of 5. For me, on a test, I want to be very clear that your y-intercept is 0, 5, because it's the point where the graph crosses the y-axis, the x value is 0. Okay, so again, thank you for watching these videos. You'll be at an advantage when we get to the tests and scenarios moving forward. Okay, so if I look at number 1, I have a function f of x equals 3/4 x plus 2. We say create a table of values. So I'm going to create a table of values, x and f of x. It makes sense to put 0 in for x. 3/4 times 0 plus 2 is 2. I would not use 1 or 2 or 3 for x. I would go all the way up to 4. So I have 3/4 times 4 plus 2. 3/4 times 4 is just 3, plus 2 is 5. 8, so that 3/4 times 8 plus 2, because I'm going to use values of x that are divisible by 4 so that I don't get fractions or decimals. 8 divided by 4 is 2, times 3 is 6, plus 2 is 8. And I could keep going, but notice that as I keep going here, every time x increases by 4, my y value is increasing by 3. The rate of change, y is increasing by 3 when x increases by 4. My rate of change, or my slope, is 3/4. So that would be my slope is 3/4, or m equals 3/4. In case you're wondering where m comes from, the Latin word for change is morph. So the rate of change is the rate of morph, m for slope. My y-intercept here, again, a lot of people want to tell me the y-intercept is 2. I want 0, 2. Okay. So let's look at a couple scenarios where we have points and we want to find the slope of a line. 2, 8, 7, 12. To find the slope of the line, we want to find the rate at which it's changing. Now notice in our table of values up here, from 5 to 8 is a change of 3. How do I get to 3? 8 minus 5 and 8 minus 4. Okay, so my slope, I'm going to subtract my y values in my numerator and subtract x values in the denominator. I have the difference in the y's divided by the difference of the x's, and they need to line up. So my second y value is 12. My first y value is 8. So the numerator for my slope is 12 minus 8. My x values are 7 and 2. So 7 minus 2. 12 minus 8 is 4. 7 minus 2 is 5. My slope is 4/5. I do the same thing every time regardless of the signs. Slope is the difference of the y values divided by the difference of the x values in the same order. y2 is -5, y1 is 4. So I have negative 5 minus 4, or a numerator of negative 9. My x values are 2 and negative 3. So I have 2 minus negative 3. Be careful of your signs here. Subtracting a negative is the same as adding a positive. So 2 minus negative 3 is the same as 2 plus 3, or 5. So I have a slope, or a rate of change, of negative 9/5. So at number 2, the line would be increasing because the slope is positive, and in 3 would be decreasing because the slope is negative. To find the y-intercept, remember y, or f of x, equals mx plus b. So I'm going to use y's for my f of x's. Notice that I have the same 2 points here. For 2, 8 and 7, 12, we found a slope of 4/5. So we're going to say that y is equal to 4/5 x plus b. Then what I'm going to need to do is take one of these 2 points and plug them in for x and y. I'm going to use the 2 and 8. Y is 8 when x is 2. So we have 8 equals 8/5 plus b. Now we need to subtract 8/5 from both sides to solve for b. B will equal 8 minus 8/5. Remember to subtract, we need that common denominator. So I have 40/5 minus 8/5 is 32/5. Now my b value is 32/5. So my line is y equals 4/5, because that was my slope, right? Going all the way back to here, I can put b in there for b. So y is 4/5 x plus 32/5. That's the equation of my line. The y-intercept, however, would be 0, 32/5. For this other line, we have a slope of negative 9/5. So y equals negative 9/5 x plus b. To find my b value, I'm going to pick either one of these 2 points. I'm just going to use the first one, negative 3, 4. Y is 4 when x is negative 3. So 4 is equal to 27/5 plus b. I'm going to subtract that 27/5 from both sides. And again, 4 is the same as 20/5. So 20/5 minus 27/5 is b. B is negative 7/5. The equation of my line then, if I take that b value and plug it in, the equation of my line is negative 9/5 x minus 7/5. That's the equation of the line. My y-intercept is 0, negative 7/5. Again, I told you earlier, WebAssign will want they'll ask for the b value, which in this case would be the negative 7/5, but the y-intercept is the point. I am fairly emphatic that way. A couple of application problems. The manager of Frozen Air Refrigerator Factory notices that on Monday it cost the company a total of $25,000 to build 20 refrigerators. 20 refrigerators were built for $25,000. On Tuesday, it cost $30,000 to build 40 refrigerators. So again, 40 refrigerators were built for a cost of $30,000. Find a linear cost function based on this information. So what I would do is I would first find the slope. 30,000, right? The second y value minus the first, minus 25,000, divided by 40 minus 20. So I have 5,000 divided by 20 is 250. That's my slope. That's my rate of change. So y equals 250x plus b. Now I need to find my b value by plugging either the 25,000 or the 30,000 in for x and y. I'm going to use, just because it's smaller, I'm going to use that first point. So 25,000 is equal to 250 times 20 plus B. 25,000 is equal to 5,000 plus B, so B is equal to $20,000. So my equation, y, or f of x, is 250x plus 20,000, or f of x is 250x plus 20,000. Now you'll notice here we want to know what is the fixed cost. The fixed cost is the $20,000. This is the fixed cost. What does that represent? Well, if x is 0, if I make 0 refrigerators, I'm still going to spend $20,000. That's the cost of paying my employees. That's the cost of running the electricity. That's the cost of sweeping the floor and all that stuff. That's my cost of buying my tools, the ability to make tools, or the ability to make refrigerators. My marginal cost is the cost per refrigerator. That's the $250. My marginal cost is $250. It costs $250 for each additional refrigerator that I make. Okay, so there's our fixed and marginal cost in an application. Demand functions. You run a small supermarket and you must determine how much to charge for hot and spicy brand baked beans. You look at data, okay? When the price is 50 cents per can, you sell 400 cans per week. So for a cost of 50 cents, you're selling 400 cans. For a cost of 75 cents, you're selling 350 cans. Notice the price went up, the amount sold went down, the demand went down. So to model this, I'm going to find my slope, 350 minus 400, divided by 0.75 minus 0.50. Negative 50 divided by 0.25. Let's find our calculator. Negative 50 divided by 0.25 is negative 200. Now that's negative 200 over 1. That means for every $1, because 0.5 is 50 cents, 1 would be $1. Every $1 I increase the price, my demand is going to decrease by 200. Okay, so I have y equals negative 200x plus b. To find my b, I'm going to pick one of my points. Let's just go with the first one, x and y. So 400 equals negative 200 times 0.50 plus b. So 400 equals negative 100 plus b. B would be 500. So y equals negative 200x plus 500. The slope. I already talked to you about the slope. The slope, or the rate of change, is negative 200 over 1. Every time I increase the price by $1, I decrease the demand by 200 cans per week. The q-intercept, or the y-intercept, right? If we're talking about quantity here, that would be a q. Let me make that a q and not a g or a y. So q is negative 200x plus 500. My q-intercept is 0, 500, which tells me that if I sell my cans for 0 cents, I would expect a demand of 500 cans. It's not super realistic, but that's what that y-intercept would mean. What about a time change? This is where the x variable, the independent variable, is time. Worldwide sales of tablet computers were expected to increase from around 130 million units in 2012 to 350 million units in 2017. So let's write those 2 points. In 2012, now I'm going to let X be 12, not 2012. So my T is the number of years. Actually, it says write it as a linear function as a time where T in years since 2012. What that's going to mean is I'm going to consider this year 0, and this would be 5 years later, year 5. So I have the point 0, 130, and the point 5, 350. So my slope, 350 minus 130 divided by 5 minus 0 is 220 divided by 5. And 220 divided by 5 would be 44. So my slope is 44. So each year, that's the same as a 44 over 1. So every year, I'm expecting the demand for tablets, or the sales for tablets, to increase by 44 million units. Okay. But now we want to find the model, the equation, the linear function, not just the slope. So y equals 44x plus b. Take one of the points. I would just suggest that you think here, take this. This is my y-intercept. This is my initial value. So that's just going to be 130 is that b. So y is equal to 44x plus 130, or f of x is 44x plus 130. In what year will I expect the computer sales tablet, or the tablet computer sales, to surpass 280 million? Now notice this is different than what we talked about before. Instead of saying if x is, now I should be using t's since we're talking time in t's. So let me go ahead and for this one change these to t's, where t is the number of years since 2012. I'm not saying in the year 2020, where t is 8, what are the sales I expect? Well, we're saying in what year would I expect sales to pass 280 million? So it's f of t that equals to 280. So 280 would equal 44t plus 130. Or in what year would I expect 44t plus 130 to surpass or equal 280? Subtract the 130 from both sides, and 44t would be 150. Divide both sides by 44, and t will equal 150 divided by 44, and that's 3.4. Now that's 3.4 years after 2012. That's 40% of the way through the 4th year after 2012. So that would be sometime during the year 2016. All right. So there's a little bit of working with linear functions models using linear functions modeling data. All right. So again, I appreciate you watching the video. Something I've not said so far, but if you find these videos helpful, it'd be great if you would like or subscribe to my YouTube channel where you're finding these videos. And I will see you next time for our next section. Thank you very much.